My goal here is to introduce some concepts and probably talk deeper about those concepts in the next meetup. Right? Everybody understands what Docker is, why Docker is, right? So we're all going from building a monolithic application into a microservice, right? Microservice is about one function, right? One capability. If I'm an application, I'm doing two things. It should be broken into two containers. That's how it is. Then only the dependencies will not be created, to the maximum extent. It's a very, it's not a nano service, it's a microservice, right? And then comes this nano or whatever the further below function as a service, right? I don't want to run the entire functionality itself as a service. I just want to run one of my function somewhere in the cloud. That's the next level of AWS Lambda and all. But basically, microservice, every one of us is trying to change the applications into microservice. You take Freshdesk. I'm sure there will be some effort going on here. How do I break my application, Freshdesk application into containers? So instead of installing once, now you'll be putting some 10, 12 containers that together form one application, right? So what I'm going to talk today is about can we think of storage itself as a microservice, right? How many people here know about SAN? Generally, have you faced any issues or have you thought about as an application developer, what are the needs of my application as far as the storage is concerned, right? You're not supposed to think if you're a DevOps engineer and if you're trying to do a microservice, you should not think anything else apart from what you're writing. That's the real we are trying to go to, right? If you're writing a microservice, everything else should be available as part of the platform. But unfortunately, today, storage is not available as a platform. And not all applications need the storage in a particular way, right? Stateless applications, stateful applications. Have you heard of this? Stateless and stateful? Is web server, what is it? Stateless or stateful? Stateless, right? If you're really deploying a web server, you will have a web server and some database in it, right? So web server can crash and come back. It doesn't care. You don't need to really know what's the status of my request, right? It has somebody called database underneath, and then it just writes it, and it expects that the database application is going to give me the data that I want, right? I, as a web service, am stateless, right? I'm a stateless application, right? But stateful applications, databases are stateful applications, right? You cannot tell a database, write this, and then database crashes, and database is expected to give the data in a particular state, right? It should not be corrupted. It should be, having a checksum protection around it, et cetera, et cetera. So that is a persistent storage need. And we are trying to do convert that persistent storage itself into a microservice so that we as application developers, even if it's a stateful application, I'm just going to write into somebody, which is another microservice, and he's going to guarantee it. Once you convert something or once something is available as a microservice, it all will be very, very simple, right? Just do a Docker pull and it's running, right? And you containerize it and it's running. Well, we'll go deep into it. So we're going to talk a little bit about containerized storage for containers. It tells a lot of things, actually, almost everything, right? We are doing something, we are solving the problem of storage for containers by containerizing the storage itself, right? So it's an open source project, uses Docker heavily, and instead of containerizing your own application within your own office, we are doing this as an open source project. Anybody can contribute it and anybody can use it. and then you can be part of the new evolution that's happening as far as the storage is concerned, right? So just to recap, because there's a Docker meetup, I'm going to talk a little bit less about storage and more about Docker itself. As I said, I want to leave this presentation with the thought that you all understood what Docker is, right? So we all know this thing that has happened earlier, right? Host operating system, virtualizing, and putting VMs. And now Docker comes and says that the virtualization is happening at OS level, right? So Docker engine, and then you put your applications as containers. Earlier we were putting at VMs. So that's the difference. But only thing is that this VM again is a OS, right? You put one application, you can do whatever you want. That application will have a database, again some management, again everything, right? But containers are not going to have more than one function in it. You're going to break each application into multiple containers, each container doing one job at a time. So you're like going further into it. That's the main difference, right? And then why Docker? It's for portability, right? Harish was standing here, Docker, you turn this side, it was like build, ship, and run any application anywhere, right? So that's the whole idea. If you're a DevOps engineer, you should make sure that it runs all the time. Of course, some of them are guaranteed by Docker itself. It runs. If I have a Docker image, it runs in almost all clouds. That's what they guarantee. But we as application developers should make sure that a container should not be doing more functions within. And then what happens is you want to change some of the functionality, you have to build it again. You have to push the image again. Then the number of images will keep going. Instead, if you have 3 functions in your application, you make them as 3 containers. Only one functionality is affected, so you change only that. The other 2 containers are stable, and you have less job to get it run, right? So basically, how do you do this whole cycle of deployment into production? You do the development, and everything is done. You do the Docker push, and your application, an image of application is there, or multiple versions of it there. Anybody can pull into the production, and then you can roll out, roll back, etc., right? So that's the whole idea of this registry. The Docker Hub is a common thing. He was talking about DTR. If you are a bigger organization, you can have your own registry out there, and then you can have some authentication around it, right? So this is the general DevOps change that's happening, right? You convert something into a microservice, you push it out onto the Docker, you pull it, and then run it instantly. A VM takes, few minutes to load at the minimum, right? A container takes few seconds to load. So that's the big thing that has been done, because you are not having any dependencies, and then they are bringing this Linux kit and everything to minimize the load time and everything, right? So Docker is going to definitely solve a lot of problems of IT. So we as application developers have to think differently, start thinking differently, right? How do I develop my application? Am I a really DevOps engineer? You ask that question after going back, then Google, what is DevOps, right? Spend some time on it. And I'm still reading, watching YouTube videos on DevOps. Every time I watch, I'll get one more point, right? So it's not easy to unlearn whatever, whoever is having more than. So I saw somebody saying, I have 13 years of experience. It's a problem now. You have to unlearn, right? So the moment you try to understand DevOps, your mind gets confused. This is not my mind is tuned to, right? So get used to creating an images that are of simple nature, right? So now coming back to what we want to containerize in terms of OpenEBS, right? Let me just go through how some of the concepts of how storage is built, right? Everybody must have seen a NetApp box or EMC box or a Dell box from storage, right? So storage is nothing but, there is standard hardware components, sometimes non-standard. But mostly it's all about, software running on top of it, right? You have a chassis, you have some disk, and you have an operating system, and then you run some software, right? So that software, once it is done, it's going to create some SAN volumes, right, or NAS volumes. And this NAS shares or SAN volumes. These volumes will have certain software, right? Now everything is there in this box. Sorry. Everything is there in this box, all the software. Volume is just projected, and now you have a big application or multiple applications in your cloud or in your environment, and then you have containerized all of them, but storage is coming from a box underneath, right? Now suddenly you have to do some production upgrade. Applications are very easy, right? That's what the Docker is helping, right? Patch testing in Visa was very simple once you move to Docker. But what about the storage? If your storage is again pointing to somebody like this, and storage, because it is software, it will have bugs, right? And then because it needs to be upgraded, then you'll have to have a downtime of the entire thing. Somebody was asking a question about service A, B, how do I do an upgrade without downtime? That's mostly a question for stateless applications. The moment you get stateful application, right, you have to take storage also into consideration for the downtime. And then now you have a monolithic kernel, and then you have thousands of containers running, and in that hundreds of them are stateful application. Then you start upgrading the storage, 100 applications are getting affected. Right? So that's the problem that we also have in storage that we typically have in applications, right? How do I do non-disruptive upgrades, right? So the solution to that is pretty simple, right? We are solving this problem in application by containerizing the application or converting the application to microservice. Why can't we do the same thing for storage itself, right? So there are multiple volumes. Each volume is associated with one container, right? If I containerize this each volume, then I just need to, push a Docker, I do a Docker pull and then upgrade this volume alone. The software inside it will be changed, and then I can do upgrade of one application. So application will have one container, corresponding storage will have one container. You can do the upgrades very, very easily. That's the whole idea, right? So this is how it is, right? Think of storage also is just one more application, and then instead of your storage software coming in a box with premium price, it's now available in open source in Docker Hub itself, right? Now, as a DevOps engineer, your life is simple. You have a lot of orchestration engines like Kubernetes, Docker Swarm to manage your DevOps thing, and then Docker. Then you'll also have OpenEBS for the storage needs underneath, right? So once these are containerized and in open domain, you are at freedom to design your application without any limitations. So that's the problem that OpenEBS is solving, right? Remove the bottleneck of being worried about stateful applications in your container story, right? So what we're trying to do is, we are, if you just look at this previous slide, here, all the software is here. iSCSI, replication, QoS management, everything is in the kernel, and then your just volume is being exposed as a LUN or a mount point, right? In a microservices-based architecture, right, we are having a kernel does not do anything, storage functions, everything is get moved up to user space. How you do the replication, how you do the iSCSI, how you do encryption, everything is moved to the user space, and then that is containerized. So basically, a volume is not just a mount point, it is an intelligent piece of software that is available as a container, and then you instantiate that. So if you are an application developer needing stateful application, you just go spin up one more, Docker run command with a Docker image that gives you some storage software running within a container, right? So now you are thinking everything in terms of containers. That's what we all should be doing, right? So how we are doing, probably, our OpenEBS user, Rahul will be showing. But basically, this Dockerized microservice is called Jiva, right? So you can, it's there in public. You can just go, if you are looking for stateful application storage, you can just do a Docker pull and then run it in any container, and that will give you some iSCSI storage, and then you can start using that, right? So it's already in public domain. So this is what all, in a nutshell, this is what OpenEBS is about, right? We take a storage volume, we Dockerize, and then make it very, very simple to be available, right? So in other words, OpenEBS is containerized storage for containers. We are solving the problem of, in a typical, how many people know application pod? There's a term of Kubernetes, right? Application pod is nothing but a group of containers where the logic of application is embedded together, right? So application pod will have today containers, multiple containers that are containerized. But for storage, you go to external SAN system, and then you link it using Docker volume plugin, or there are many methods, right? That's how you do that. Even if you're launching a container in AWS, then they will say, connect to a storage volume that's there in EBS, right? Elastic block storage of AWS, and how you're connecting is through some way that Docker or Kubernetes provides, right? But essentially, the storage volume is not in your control, right? Its storage is an infrastructure piece. It's not in your control. It's running elsewhere. With OpenEBS, you think a little differently. Storage is not an external piece to you, right? It's another container, right? It's just, as an application developer, I want to see how application pod YAML looks like, right? YAML is my configuration file for application. I want to say, this application is for MySQL, and here is the database location, and here is the storage location. Here is the number of transactions per second I would need. Here is the memory I need. All that you put, and then say kubectl create, or in Docker Swarm something else, right? You set the configuration for an application in a given file and run that file. Your application is running, right? It takes the resources wherever it's required, and because the application pod will have multiple containers, one of the containers can be a storage container, and it automatically gets created, it gets associated. Now, if the application pod is moving from one physical machine to another physical machine, everything gets moved, right, including the container that is meant for storage, right? So basically, application pod management takes care of storage volume management. That's the biggest value add this storage is going to bring to you, right? So if I have to say in a very simple terms, OpenEBS solves the persistent storage issue for containers. You don't have to think in terms of, what do I do about this storage for my application? It's just one more container. You continue concentrating on your actual application, not on underlying storage, right? So how do we deploy? We are still early stage. We are at a 0.2. A 0.3 release is coming next month. So you can deploy it on a separate Docker machines, right? If you want to build a storage platform specific to a given host, you can containerize that entire storage controller, or you can just take an existing Dockerized platform and then put our software, OpenEBS, into that, and then convert that into a Dockerized storage, right? We also have another component called Maya. It's about managing the storage volumes. You have thousands of volumes. How do I manage, right? All this thousands of volumes are available as thousands of containers. So either Docker Swarm or Kubernetes is going to take care of basic management of the storage provisioning. But storage has some other work, right? Data protection. have to back it up, you have to restore it. People will complain if you are in IT, I want to restore my file, right? There are two types of storage companies, right? Half of them are trying to, give you the data, and all the other companies are trying to protect your data, right? So storage protection, data protection is a big operations. So we take care of all those related functionality in terms of OpenEBS Maya, right? That's about Maya. I'm just introducing some of the concepts. You go and I encourage you to look at OpenEBS as an application of how Docker is being used, right? If you are trying to learn a little more about a DevOps, or want to be a good Golang programmer, OpenEBS is a good project to hang on to. It's a new project, so you can be the early contributor. It's out of Bangalore. All the developers are there, and we plan to come here and spend some time with the community here. So if you are trying to contribute and then become an open source programmer, this project can be a good start, right?
There are differences in this.
DR, yes, the entire setting up itself is different here. You basically you take the DR also to the application level, right? We will give you some sample files of Percona database, right? I want to have 2 copies, one here and one as a DR copy. That gets translated, it's spun as a separate container elsewhere in the cluster. That's all taken care by Maya, right? So the storage admin will probably not have much headache as he's used to, right? Everything is moving up the stack into the application microservice level, right? So without OpenEBS, how does this general DevOps work, right? So you have a status application, you use Kubernetes, you put all whatever you want into that file, and then it gets the intent is expressed, and then everything gets provisioned. But same is not the case with stateful application. Today's stateful application needs a lot of hardwiring to the storage. You are taking multiple SAN volumes from here, there, and then the moment the container moves from one host to another host, you have to be very, very careful about what happens to my persistent storage. And the moment you think about what happens to my storage, you'll say, I'm an application developer, storage needs to be taken care by somebody else. Then you are actually not solving this entire DevOps microservice functionality, right, in your organization, right? So that's the problem for stateful. So with OpenEBS, there won't be any difference between a stateless application and a stateful application. You continue to put your storage needs into a YAML file that gets no changes in the DevOps workflow. You don't really worry about is this application a database, or is it a web server or something else. If you need storage, you just express that needs or requirements into a YAML configuration file, and then OpenEBS will take care of it, right? So it goes into the OpenEBS policy engines, and then it gets through the EBS APIs, and then it gets done. So that's how we are really solving this persistent storage issue, right? And DevOps operations with OpenEBS is really, I don't need to worry about the applications being stateful or stateless, and storage operations, data protection, DR, all other needs, I need not worry in a big way. Of course, you need to learn how this entire thing works, set it up, and then things will work. But the whole goal of OpenEBS is to ease the DevOps people from the worry of what happens to my stateful storage, application storage, right? So why am I here, in Docker, right? Meetup, Docker Meetup, right? So the entire storage containerization is built using Docker, right? We don't support Rocket yet, but mainly, we expect Docker to solve the needs of whatever the underlying issues that are required for microservices, right? So storage orchestration, we are currently integrating with Kubernetes. How many people are already working with Kubernetes? Very good. So, we might support Docker Swarm and few other platforms later, but basic idea is that most of the organizations are trying to get into, Docker as the underlying platform, but for containerization, Kubernetes is probably the preferred choice. So we are going with that. And deep storage operations that is not done by Kubernetes, we are solving by another Kubernetes service called Maya. Maya is just another service inside Kubernetes. You run it. It will take care of the management operations of the storage that are not taken care by Kubernetes itself. So it's not a totally different box or something, right? And core storage features, of course, we are writing in open source. So the latest of intelligent storage requirements are all being fed into OpenEBS. If you are data science engineers or machine learning enthusiasts, there are a lot of work being done at the core storage feature level, which is in open source, right? So feel free to dig in and then be part of that community. It can be a thrilling journey for you guys if you are interested in data science, right? So just if somebody asks you what is OpenEBS, right? How do I tell? Of course, our tagline is containerized storage for containers, and then you go and say whatever Calico and Flannel is doing for networking, OpenEBS is doing for storage, right? Calico, Flannel, if you're networking guys, you may be obviously knowing what these projects are, and we are the only open source solution for storage, which is built with the purpose of containerization, at a storage level, right? Ceph is also there. How many people know Ceph here, right? So obvious, the first question is, hey, what's wrong with Ceph? There's nothing wrong. It was built a little earlier. So we are building OpenEBS ground up with the needs of containerization. So, overall, you will not be worried about storage in general with OpenEBS when it's deployed, right? So I just run OpenEBS just like I run Kubernetes. So there's no difference. That's another way of telling what OpenEBS is, right? And eventually, why somebody has to, if you're a DevOps engineer or somebody who's doing something with DevOps, why you have to be worried about OpenEBS is because it will take all your worries about storage off your back, right? Once you learn and then puts into automation, storage, is expected to run very, very smoothly. So I encourage you to learn a little bit about stateless, stateful if you're an application developer. Slowly we are learning what is Docker, how do I Dockerize my application, then how do I scale it, and then how do I persist my data. These are all the multiple steps, right? So if you're at what is Docker, probably storage is a little bit 3 months down the line you will worry about the application storage. But for the guys in general who's trying to put their applications into production using Docker, think about how do I solve a stateful persistent storage issue that's there in the containers today, right? It's a very well recognized problem. Multiple people are trying to solve, and OpenEBS is one of the main guys who are trying to solve this particular problem as in a holistic manner, right? And there are multiple other people who are trying to solve the same issue, or storage solutions are available. How many people are aware of this? Infinite is from Docker itself, right? We still don't know much details about what Infinite is, right? But certainly, Taurus was from CoreOS, which was recently shut down, and there's another project called Rook, which is a management layer on top of Ceph, I would say. So probably, that's also another solution that's expected to solve some of these problems. And Portworx is another very similar solution to OpenEBS, but that's not open source, right? Fully open source. So typical use cases, of OpenEBS is you're going to use it for data science applications and any other stateful applications like Cassandra and other databases, right? And main thing that we are expecting to see is just like, TDR was there, right? DTR, Docker registry, right? So the whole idea of registry is I want Visa customer to have their registry of their own, either on-prem or somewhere in the private cloud in the cloud, right? So same thing will be applicable for the storage itself, right? I know there is a Amazon EBS or Google Persistent Disk, but I don't want to go there and put all my data. I want to build one on-prem storage platform, very, very similar to what Amazon AWS EBS is, right? So you want to have, just like a private cloud in your own on-prem with all virtualization, there is a need today that I want to build entire containerized storage platform, containerized infrastructure platform in my data center itself, right? I have 100 applications, I'll move 80 of them to cloud, but probably 20 of them I cannot move for some time. But I want to make sure that I take advantages of all this containerization, right? So how do I keep my applications on-prem? Okay, take Docker, fantastic. You run it on Kubernetes. What about storage, right? Storage, you don't want to hook it onto SAN, right? And then again, employ multiple people, solve the headache. Storage is 50% of the headache usually, right? You're solving only the other 50% if you're doing. So using OpenEBS, you now have a choice to deploy a storage platform similar to either Google Persistent Disk in cloud or Amazon EBS in cloud. The same thing you can do the platform in your on-premise itself. So that's the expected use case that will be very, very popular, right? So with that, I'm just going to skip some of these slides. I've shared the slides in SlideShare and put it on the forum, so please go through that. I'm expecting to come back in the next meetup and probably give a little more focused demo of this entire solution, right? So right now, Rahul is going to show how this Docker image of Jiva is going to be pulled, and then you can quickly bring up a simple persistent storage volume using Docker, right? So with that, I'll probably take one or two questions and then hand it over to Rahul.
What is the impact on the performance kind of adds another layer?
That's the general perception. Containerization adds one more layer. Storage basically, is going to go over network to a particular network port, iSCSI, right? So you are running that port over this Docker layer. Docker itself is evolving very fast, right? Compared to the network latency between the application and the storage endpoint, the additional layer that you add will be very, very minimal, right? So how we are actually, we are going to perform much better than, what it would be without this Dockerization, because storage, there are multiple other intelligence layers that we are adding within the storage. Typically, there will be 1 or 2 milliseconds total latency expected within the storage box. If you look at the disk underneath, it will be like sub-millisecond. So there's a lot of time spent within the storage stack itself. So we are making a lot of improvements with our whatever experience that we got, and including hot data tiering and all. So if you push your NVMe flash onto one of this, then you're going to respond very, very fast, and we are going to be more intelligent about what data to be hot tiered. Right now, this kind of intelligence is available only in the expensive legacy solutions. But first time, we are going to bring some of them into the open source model, where you will see OpenEBS is running much faster than any other solution, just with additional flash cache that is added, right? That's definitely a concern. There are other concerns like security. What happens with my data? Docker itself has to, is dealing with some of this underlying kernel security, additional needs. That will all be solved in the next few months, I would say. That's why we are banking on Docker, right? We are not going and trying to solve some of these problems in Docker. We expect the Docker. There are so many people who are depending on Docker, so all these issues will be solved with respect to security. But with respect to the latency, it's a very good question. We cannot avoid that little latency, whatever the microseconds that is added. So you improve wherever you can do better, you do that and come out more effectively, right, with a much lesser latency than traditional application. Yes, yes, definitely. That's the whole idea. We don't want to say that, push your new storage. It's not meant for greenfield. It can consume an SCSI learn from your NetApp box or EMC box or wherever it is, even Ceph box. And then this OpenEBS goes as a software into a hyper-converged mode and then expose it as a containerized storage. Yes.
If you want to talk about databases, how is it different from something like RDS or any other database as a service if I go to AWS?
Say it again.
This is actually I have to manage storage, whether it's OpenEBS or the actual SAN. If I just get a database, is it superior to something like RDS that take a service itself from AWS?
That is a total service itself, right? Database means, they are, what happens if your application needs a bit customized, your own application, you need to containerize it, right? You have a choice to take, AWS database as a service and try to link it to your application, but you are now getting tagged to them, right? Or Google, that's not what you want, right? You want to run the same thing in your own on-prem, right? So today solutions are available: AWS, GCP, Azure, right? Fortunately, there is some competition among them. Otherwise, it would be even. So the whole point is, we don't want to be locked down to anybody, right? You want to be in control of the perfect software, right? So, is this useful in general? I know usually storage is not a very common subject. That's why I'm asking. Useful? No? Yeah? Okay, thanks. Rahul will probably, this is just a quick note about our roadmap. We are doing aggressively. We are about 10 plus developers working out of Bangalore, and I'm planning to expand more user as well as contributors base in Chennai. So you will see me or my other team members coming and talking a little more about all these things. We'll be actively participating in Docker meetups and Kubernetes meetups in Chennai. So feel free to come on to our Slack channel, look at it either for becoming a better DevOps person, or if you really want to solve challenges in storage domain, you can contribute to it. If you just want to learn how things are being Dockerized, you can also come and ask questions, learn. So it's a more practical forum, right? Docker platform itself is huge, right? There are about 1,000 contributors. You don't know where to contribute more. But here is OpenEBS. It's a small project that is starting out. And if you are having some cycle to spend and become an open source programmer, this may be the project because it's nearer to you, right? Also, do we know the concept of GitHub starring? This is another thing that I'm observing among us, right? So, Evan Powell, our chairman, when he first launched the OpenEBS meetup in Bangalore, he expected, there are 20 people and all 20 of them are going to give stars, or at least, one or two less, right? Eventually, this is another culture type of a thing, right? Just like we have to move towards DevOps thing. It's a way of you following up certain projects. You have a GitHub profile, and then you follow which projects. You follow them because you are interested, so you star them, right? So do star us. This shows that this database is this open source project is becoming more popular. how do you say, how many, how popular is Docker? You say so many contributors, so many stars, so many check-ins. So this is how you do. So feel free to, go to this OpenEBS project and give us a star if you think that you have to be following it.